Welcome back to my channel. I'm your host Mohan and you are watching the MS SQL DBA series. Today we are going deeper into the heart of the engine. We are going to learn all about the database files, log files and database configurations. Understanding how SQL Server actually stores your data on the disk is what separates a basic user from a pro database administrator. Now, before we jump into the technical details, I have a small request. If you have been watching and following this series, please take a second to subscribe to the channel and hit that like button. I also love reading your comments. Whether you have a question or just want to say hi, please drop a message below. It takes a lot of time and effort to put these deep dive videos together, and your support really motivates me to keep creating high quality content for you. All right, enough with the intros. Let's move to the next slide. In our last videos, we have covered the fundamentals and DBA roles. We have also seen the installation and the configuration. In the last video, we have discussed about the SQL Server architecture and the system databases. In today's video, as I said, we are going to look into the database and log files, what are the file groups, and how the settings are configured for databases. In today's video, we are going to learn about the log files and data files. We'll look into the user databases, different settings in the databases. We will see the recovery models, compatibility level, containment, and we will see different database properties. And in the last, we will look into the interview questions around the topic and the explanation. Now let's move to the next slide. When you save data in Microsoft SQL Server, it is physically stored in files on your hard drive. There are two main types of files: data file, which hold your actual data in the form of tables and indexes, and we have the log files, which actually track all the changes you have done in your database. Any database in SQL Server will have at least one data and one log file, and without these two files, the database can't be started. Let me show you where you can find those data files and log files information. For that, let me switch to the SQL Server Management Studio. Here is my SSMS, and here you can see one test database. You need to right click, go to the properties. We can expand it, and you can go to the files. In the files, you can see I have three files, and two of them are the data files, and one is the log file. Here we have file groups as well. We'll discuss about it later. And you can see the file name as well and the location of the file. Other way of looking into this is using the query. So if you run asp_help db and the database name, you will see all the information about the files. Here are the names, and this is the location. This is the file group. So here you can see all the information about the data files. Now let's go back to the topic. Guys, into two categories. Let's start with the most important one, that is the primary data file. Every database must have exactly one primary data file. It usually ends with a .mdf extension, but this .mdf is not fixed. You can give any name you want. For example, what we have given as .ms, .ls, .lm. So these extensions are not fixed, but to maintain the standard, we keep it as .mdf for all the primary files, .ndf for all the secondary files. So you can think a primary file as a master file for your database. It handles the system information, so it stores the database catalog, which is the table of contents for your database, and it will have metadata about your tables and about your views. It will have the pointers, so it contains the addresses of all the files in the database. By default, all your actual data and tables are stored here unless you tell SQL Server to put them somewhere else. Next is the secondary file. Secondary files are optional and usually have .ndf extension, but again, it's not fixed. You can give it anything. You don't need secondary file for a database to work, but DBAs use them for two main reasons. One is for the better performance. By creating secondary files on a different physical drives, the database can read and write data faster because multiple disks are working at the same time. Other reason is for the growth. If your database becomes too large for a single disk, you can add secondary files on a new empty drive to keep growing. Next is the file groups. To keep things organized, SQL Server uses file groups. A file group is just a logical container of your database files. Please remember the point that log file is not part of any file group. Let me show you the database details again. Here you can see we have file group for primary and we have file group for secondary data file. But this is a log file and it does not belong to any file group. This question may be asked in the interview that what is the file group of log file? This is just to confuse you. You can say that log file is not part of any file group. And when you query the database, you will see it as null. So every database has a default group called the primary file group. This contains your primary file and any other secondary files that you haven't assigned any other file group. So in the starting, you will have one data file and one log file. And if you create another data file or secondary file, and if you want to keep it in other file group, you can do it. Or if you don't assign any file group, it will by default go to the primary file group. You can also create your own file groups. This allows you to place specific or heavy duty tables on your fastest hardware to improve the speed. So what is the advantage of file groups? This is the question being asked in multiple interviews. So as a DBA, you view file group as a tool that gives you control over your hardware. Without the file group, SQL Server just treats your disk as one giant bucket. With the file groups, you can be very specific about where your data stores. So the advantage includes the performance. So how it increases the performance. File groups allow you to map specific tables or indexes to a specific physical disk. You can place your most heavily used tables on a file group and keep that file group in a fast drive like SSDs, while you can keep your rarely used tables on cheaper and slower HDDs. If a file group contains four files spread across four different disks, SQL Server writes data to all of them at once using a proportional fill algorithm. This effectively multiplies your disk speed. Next advantage is the partial restore. In a huge database, let's say 5 terabyte or 10 terabyte database, a full restore after a crash could take an entire day. If you have file groups, you can restore the primary file group and your file group with most used data first to get the business running. While users are working on the restored data, you can restore the rarely used file groups in the background. The database stays online even if one secondary file group is still being fixed. Is maintenance. You can mark an entire file group as read-only. This is great for archive data. Once it is read-only, SQL Server does not need to perform locking for updates and you only have to back it up once. And by this, you can save massive amounts of backup space because you are not backing up the rarely used data every night. Instead, you are backing it up once only. Other thing is you can also specify a file group when rebuilding an index. This allows you to move an index to a different disk during the rebuild process to balance the space. Last advantage is administration. If you are in a shared environment, file groups help you to manage different tenants or departments. You can put up the marketing department's data in one file group and the finance department data in another file group. This makes it easier to track how much disk space each department is actually using and allows you to move them to different tiers of storage independently. Now let's understand how the data is getting stored in SQL Server. In SQL Server, the smallest unit of data storage is called a page. Think of a page as a physical box on your hard drive where SQL Server keeps your data. This is the architecture of a data page. A page is divided into four distinct sections. First is the page header. This is at the very top. It stores system information like the page ID, the type of page, data pages or index pages or IAM pages, and how much free space is left. Next is the data rows. This is the middle section where your actual table records or the data are stored. Rows are placed one after another, starting from the top after the header. Next, we have the slot array, or we also call it as row offset array. This is at the very end of the page. It is a set of 2-byte pointers that tell SQL Server exactly where each row starts on the page. It grows backwards towards the header. Next, we have reserved or free space. Some bytes are left unused to account for potential updates or alignments. So now, as we know that the rows are stored in the pages, let's see what can be the maximum row size an 8K page can hold. The size of the row depends on multiple factors like column data type, actual data, row compression options, and others. Now, as we know that the size of our data page or data block is 8K, so it will have 8192 bytes. Out of this 8192 bytes, 96 bytes will be occupied by page header. And if it has only single row, then 2 bytes will be for that particular row offset array. If we have multiple rows, in this example, we have 3 rows. So it will have 2 multiplied by 3, 6 rows. But here we are considering only one row, so we can say that we have 2 bytes for that particular row. So 96 byte for page header, 2 byte for the row offset array, and SQL Server also reserves 34 bytes for internal engine. These 34 bytes are reserved for system use, including checksum and torn page detection. So now we can say that total usable bytes will be 8192 minus 92 plus 2 plus 34, so it comes 8060 bytes. So 8060 bytes is the maximum amount of space a single row can use on a SQL server. Let's understand what are the extents. To manage efficiently, SQL Server groups 8 contiguous pages together into a larger block called an extent. In SQL Server, we don't just manage one page at a time, we group them into the extent. Think of an extent as a pack of 8 pages that sit right next to each other on the disk. Since each page is 8 KB, one extent is 64 KB. There are two types of extents. First is the mixed extent. These are shared by different objects. Each of the 8 pages in the pack can belong to a different table or indexes. SQL Server uses these for very small tables to avoid wasting spaces. Here you can see first page belongs to table 2, second index page and third index page it belongs to different other objects, and we have table 2, table 3, then index 3, table 2 and table 3. So these can belong to different objects. Next we have the uniform extent. So these are dedicated to one object only, like a single table. All 8 pages in that extent will belong to single object. SQL Server uses these for a larger table that needs a lot of space. This is all about the extents. Now let's understand what is the page split. So page split can occur in a table which has the primary key or a clustered index. So consider this example where we have an employee table and it has a primary key or clustered index on employee ID column, and this page is full and it can hold only 10 rows. So we already have a rows with the employee ID details with the employee ID 1, 2, 3, 4, 5, 6, 9, 10, 11, 12. We have all those 10 rows inside this full page. But now if we try to insert the data about employee whose employee ID is 7 or 8, then such cases there is no space inside the page, then this page split will occur. So when this page split occur, half of the rows will be moved to the new page. So before page split, we had a full page. After the page split, we have two pages, and both are half full. Means half of the rows will be in the older page, and half of the row will be in the new page. So this is an example of page split. In the production database with millions of rows and random keys, splits can happen thousands of times per minute and leading to the high fragmentation. When the page split occurs, SQL Server have to do a lot of work. It has to log the changes in the transaction log. It also requires I/O to write the new page and update the pointers. It can cause brief locking on the pages that are involved in page split. And page split can significantly increase the fragmentation, both the internal fragmentation as well as the external fragmentation. So what is internal fragmentation? So now both the pages have 50% free space. If no more inserts fill them soon, you are using the 2 pages of what could fit in 1.5 page. So we are wasting the space. Over many splits, pages average lower density, leading to more page scanned during the queries. So it will lead to the internal fragmentation. And what is the external fragmentation? The new page number 2 might be allocated from a non-contiguous extent on the disk if the free space is scattered. If you run a page scan or if you run a range scan, that is select a star from employee where employee ID between 1 to 12, SQL Server might lead the page 1 and then jump to page 2 elsewhere on the disk, increasing the I/O time. Fragmentation percent could rise from 0 to 50% after the page split. If more random insert happens, the more split occurs, and it will compound the fragmentation, and in the result, it will definitely decrease the performance. Let's understand the very important part of a SQL Server database, that is a transaction log file. Every SQL Server database includes a transaction log, which acts like a detailed diary or a black box recorder for your data. It keeps a record of every single change made to the database and every single action performed by the users. So why is it important? Think of a transaction log file as a safety net. If your database crashes or if your system loses power, SQL Server uses this log to see exactly what was happening right before the failure. It uses this information to undo all the incomplete tasks and redo all the successful ones, ensuring your data does not get corrupted or lost. By understanding transaction log architecture, you can do much better job of managing your database. So first, let's understand what this transaction log file records. So it records the transaction starts and the end of the transaction. It records all the modifications like insert, updates, and deletes. It will also record the table index creations or deletions. It will record the space allocation like extent and page changes, and it will record the rollback operations themselves. So logically, SQL Server transaction log is an ordered sequence of records that tracks every change to the database. And every log record will have a log sequence number. We also call it as LSN. This LSN is a unique and increasing ID. It will have information or it will have the pointer to the previous and the next LSN to maintain the log sequence number or to maintain the log chain. So the log file is a wraparound file. It is divided into many smaller segments. We call it as VLFs or virtual log files. So there are two ways to check the VLFs. Let's go to the SSMS, and here I can run command dbcc log info, and I will give the name of the database. And if I will execute, I can see there are 4 VLFs inside the transaction log of this test database. And out of those 4, only the first one is the full or it has some data. Others 3 are empty. So this information is very important when you are troubleshooting the log file full issue. So when if you see that there is, if you see the issue of log file full, and if you run this command, you may see all the columns or all the rows of this status column will be 2. It means the file is full. And when you take the log backup or when the transaction is completed, you will see few of the files will be 0. It means the file is empty now. That particular VLF is empty now. But it is very important, if you see the status column and if you see the 2 in the last row, it means you cannot truncate the log. And there is another way of checking this VLF. It is by writing select star from sys dot dm underscore db underscore log underscore info, and I will give the db id here. This is another command we can execute. Here we will have the detailed information. Here we can see the VLFs, VLF first LSN, and this is the LSN, and the format have the VLF ID that is 00025. Then we have block ID that is ending with 010, and then we have a record ID that is 001. And this is how we can check the information about the VLFs. Now let's go back to our slides. There is one more concept that is called the active log. So in this picture, you can see we have 4 virtual log files, and first 2 are unused and 3 and 4 it is in use. And we have this minimum LSN or min LSN. So as I said, LSN is a log sequence number, and this min LSN is a log sequence number of the log record that is required for the recovery of the database, because before this min LSN, every record is every transaction log or every transactions are completed, and this is the min LSN. After that, all the records, all the transactions are still not completed. So here we can see start of the logical log and end of the logical log. It is not same as the start of the physical log, because physical log file is starting from here, but logical log will start from where we have the data or we have the transactions, because these two are unused and these are empty. So we can see that logical log is starting from here and it is ending at the end of the physical log file. Now, if there is any insertion, updation, or deletion that needs to be recorded into the transaction log, then it will go and check for the first VLF. If the first VLF have some data, if the first VLF is unused, then it will use that particular VLF. And if there is no space in the log file, it means if there is no space in the VLF1, then it will enable the auto, if it will trigger the auto growth. And if the auto growth is not enabled, it will give you the error log file full and you will get 9002 error. That is very important to understand, that you should enable the auto growth in the log file, and you can choose the auto growth very, very carefully. You can read more about it, because your auto growth number or percentage will decide that how many virtual log files it will be created. If you have multiple virtual log files, then there will be a lot of time in recovering those database, because in the recovery process it will check all the virtual log files. So you will check, or you can read more about the virtual log files and auto growth relation. That will be helpful for you to understand the transaction log file. Now, as we have understood the transaction log file architecture, let's create a database. For that, I will go to SSMS. Here we have a database test already in this server. So I will show you few of the ways to create a database. So if you right click on the database, you can see new database option, you can see the attach option and restore database options. So these are the three options by which you can create a database. And here I am showing the GUI. You can also create database by using the script or the command. So I'll click on new database, and here I need to give the name. I will give as test2. The owner, I will keep it as SA. You can keep it as default. So your username will come as a owner. We have logical name, file type, file group, initial size, auto growth, path, and file name. So if I will not write anything here, you can see the logical name is empty. And once I will type the name of the database, the logical name will come by as per the database names. And if you are creating a database using your commands or script, then you can give different name as well. Even here also I can give different name like this. So this is the default one, but you can give as per your need. Second one is the file type. So yeah, so database will have a database files or log file or data file will have logical name as well as the physical name. So this file name will come after I create a database. So here this is the logical name, then file type. As we have seen that we have at least two files in our database. One is the data file and other one is the log file. So here you can see the two files, and this is the file group. We have already talked about file group. The log file is not part of any file group, and this is the initial size of the data file and log file. You can also change it, but please make sure that these settings are the default settings and these are coming from the model database. If I will show you the model database here, you can see whatever the settings here in the model database, it will come by default in your new database. So here it is having 80 MB of log file and data file. That is the reason you are seeing here the size as 80 MB. If you try to create any, if you try to create a size below this file, below this 80 MB, it will not work. For example, if I will get 50 and I will click OK, it will give you an error. An error says that the create database statement failed. The primary file must be at least at 80 MB to accommodate a copy of the model database. So we need to make sure that it will have minimum 80 MB. And then we have the auto growth and max size. So this is very important setting. What does it mean by auto growth? Consider there is a file and it has 80 MB as initially, and this 80 MB is completely full. And now if this auto growth setting is disabled, if you don't enable this auto growth setting, if you click here and it is saying as none. So this ATMB file will be full and you will not be able to insert any data in this database, and you will get the error that your database file is full. And if you enable this auto growth setting, you have two options. One is in percentage and one is in the megabyte. For the smaller database, we can keep this setting as in percentage because this ATMB is very small. And once this ATMB is full, if I will keep it as 10%, then 10% of ATMB will be 8 MB. Then this file will be incremented by 8 MB. And next time it will be having 88 MB as initial size. And if this 88 MB is full, then again 8.8 of this, like 10% of 88 will be 8.8 MB, and then file will be incremented by 8.8 MB. And if I keep it in megabyte, so once this 80 MB is full, it will be incremented by 64 megabyte. So the recommendation is for the smaller database, it is okay to keep in percentage, but if your data files are like in GBs, then it is recommended you will keep it as MB because this percentage will be huge. So just consider that your data file is 20 GB in size, then 20 GB, 10% of 20 GB will be 2 GB, and increasing this 2 GB at once will definitely have the performance impact as well, because it may hold the operations of the database for some time, and until your file is incremented, you will not be allowed certain operations in the database. So please keep it very uh, carefully, whatever size you are choosing, whether you are choosing the in percentage or megabyte, you should be very careful. And then we have the maximum file size. Here I have kept as unlimited. It means it will take all the space of the drive on which I have kept this database file. And if I'll keep it limited, so for example, if I keep it limited as 100 MB, so once this 80 MB is incremented and it will reach to 100 MB, it will give you error that your database file is full. Then you can come here and you can increase this limit. This is just to control your size or your growth of the database. Then we have the path, and the file name will come later, as I said. And in the options, you will see certain things. One is the collation, and you can keep the collation. If you keep it as default, this will take the default configuration of your SQL Server instance. You can keep another, you can keep the collation as per your need as well, because sometimes your client may need certain collation for the database. If you are working in a environment where multiple clients have the database in the same instance, then you can keep different setting as well. Recovery model, compatibility level, and containment type, I will explain you later. And there are a few settings in this area. Those are auto create stats, auto shrink, and auto update stats. So I will explain few of them because I cannot explain everything. It will be a too long video. For the auto create statistics, so when you run a query, your SQL Server optimizer needs to know how the data is distributed. It means where your data is located, in which data block, which file, in which drive. And this optimizer will use this data to pick up the fastest path to run the query. So if the specific statistics it needs and it does not exist, this option allows SQL Server to build them automatically on the fly. So the recommendation is you keep it as on. It helps the database make smart decision without you having to manually create statistics for every column. The catch here is on very large tables, creating these stats for the first time might cause a slight delay in the very first query that triggers it. Next, we have the auto update statistics. So you know that so we know that data changes over time, and if you add millions of files on if you add millions of rows on a table, then the old statistics are now stale. So this option tells SQL Server to automatically refresh those statistics once a certain amount of data is changed. So approximately if your 20% of the table data is changed, then it will trigger the auto update the statistics. And again, you can keep it as on because outdated statistics are a leading cause of a slow database performance. It will create bad execution plan. Then we have the auto shrink option. So the option tells SQL Server to constantly check for the free space inside your database files. And if it finds a significant amount of empty space, it automatically shrinks the file to give the space back to the Windows operating system or to the disk. So recommendation is you need to keep this auto shrink option as off, because in most of the production database, or almost all the production database will have this setting as off. And because when you shrink the database file, it will create a fragmentation. It is just like taking a deck of cards and shuffling them violently. It ruins the physical order of your data and it will create a fragmentation that will make your future reads very slower. Consider if you are keeping this auto shrink option as on, your database shrinks the file. The next day, your data grows again, and the database has to auto grow again. And this constant cycle of shrinking and auto growing will take a massive amount of CPU and disk resources. So we always keep this auto shrink option as false. Then we have these options. You can read more about them if you need it. And then we have state. So this is a read write database. So that's why it is false. If you want to make it as read only, you can make it as true. Then we have database states. It is normal. I will tell more about the states later. Then encryption. If you enable the encryption, then it will be true one. And restricted access, you can have multi-user. That is the current mode. And we can also use a single user and restricted user. Then I can create this database. I'll click OK. Here you can see our database is created. Let's go to the properties. We have the name of the database, status, SA is the owner, this is the date on which it is created, this is the size of the database. It will include the data file and log file size. This is the total space available, and here it is for users. Here we will also see the last database backup details and the last log backup details. We haven't taken any backup, that's why it is none. Then we can go to the files. Here you can see now the physical name of the files, right? And here the owner is SA, all the settings which we have configured. You can see here, this is the path of the data file and log file. Then we have options here. In the options, we will have the recovery model, collation, compatibility level, and containment. I will explain this later. And these are the settings we have already seen. Then we have change tracking option. If you enable the change tracking option, you can enable from here. And we have permission mirroring. And if you want to configure the mirroring, you can configure from here. This is a high availability option. And then we have a transaction log shipping as well if you want to enable it. And you again, this is a query store. If you want to use the query store, you can keep it as on. So this is the settings of the database. Now let's understand what is the recovery model. In SQL Server, a recovery model is a database property that determines how transactions are recorded in the T-log or transaction log and how much data you can recover in the event of failure. So this will tell you the point where you can recover your database. It will depend on the recovery model. There are basically three types of recovery model: simple, full, and bulk log. So let me show you how you can see the recovery model in SQL Server database. There are multiple ways to check it. First way is to right click on the database, go to the properties, and you can go to the options. In the options, you can see the recovery model of the database. In the options, you can see the recovery model of the database. It is a full recovery model, and whatever database you will create, the recovery model, the default recovery model will depend on the model database. Here, if you keep the recovery model of the model database as simple, every database which you will create by default, it will have the simple recovery model. If the model database is full recovery model, in the full recovery mode, then we will have all the database which will be created. Those will be having the full recovery model. And we can also check the recovery model of database by using the sp underscore help tb command. This will tell you the recovery model of all the database. You can just expand this column, and here you can see simple, full, simple. So, and there are few commands as well that you can use to see the recovery model of the database. So the first recovery model is simple recovery model. We call it as a low maintenance option because the transactions log are automatically cleared or truncated as soon as the checkpoint occurs. And simple recovery model does not support the log backup. It only supports the full backup and the differential backup. So checkpoint is not the only option when this database with a simple recovery model truncates the log. There can be multiple other reasons when the transaction log will get truncated. When the transaction log of the database with the simple recovery model is about to full, then it will trigger the internal checkpoint and it will clear the log. And when you are backing up the database, even if you are taking full backup or the differential backup in case of simple recovery model, then it will truncate the log. Or whenever the database is starting or when they are in the recovery, then this truncation occurs. Other reason can be when you are changing the recovery model from full to simple. In that case also the transaction log will truncate. So there can be multiple reasons of truncation of logs in the simple recovery mode. or simple recovery model. Next is the full recovery model. So this is the standard for a production database, and in most of the production database, it will be the full recovery model. But there are a few consideration while you are keeping the database in full recovery model. You must enable the log backup of that particular database if you are keeping it in full recovery model. That is the standard practice. Otherwise, your log will not be truncated and it will be full, and you will not be able to insert anything in the database. So this recovery model, it tracks every single transactions in the log until you manually perform a transaction log backup. And here you can achieve the zero or minimal data loss. It allows point in time recovery, means you can restore the database to a specific time when your database got crashed. So this is best for the mission critical production systems. And as I said, you must take the regular log backups or the log file will grow until it fills your entire disk. So please make sure that you have the log backup enabled for the databases which are in the full recovery mode. Next one is the bulk log recovery mode. So bulk log recovery mode, you can say it is a hybrid model. It acts like a full recovery mode, but whenever there is a bulk operation like bulk insert or select into or index rebuilds, it will only log minimally, and this will speed up the performance and it will also save the log space. But here, one thing to consider that in the bulk log recovery model, you cannot recover your database till point in time if at that time the database has those bulk log operation like select insert or bulk insert or select into and the index rebuild. So here while you can back up the logs, you cannot perform the point in time recovery. So it is ideal for temporary use during the large data imports or maintenance windows to prevent the log explosions. So these are the recovery models of the SQL Server database. Now let's move to the next one, that is a compatibility level. So in the compatibility level basically controls two main things. One is the syntax of your T-SQL statements, and other one is the query performance by using the optimizer. So here, what is the meaning of these compatibility level? Every SQL Server instance version have specific compatibility level, and this compatibility level defines how your SQL query reacts and how the optimizer will choose the plan. So if we talk about the syntax and language, so some more we have some modern commands like string underscore AWG or generate underscore series. Those will only work if the compatibility level is high enough. Or in some of the compatibility level, earlier compatibility level, we have few of the keywords that we could use in the query, but in the higher compatibility level, those have become the reserved keywords. So you cannot use that. And it also, change the, it also it is also important to understand that the compatibility level defines the behavior of the SQL commands. It affects how SQL handles small things like how it converts dates or how it handles certain math operations. And as I said about the query performance, this is the most critical impact. Every new version of SQL Server has a smarter query optimizer, and when you upgrade your compatibility level, it will unlocks the intelligent query processing features that can make queries run 10 times faster without changing any code. These are some of the compatibility level as per version. SQL Server 2016 will have 130 and SQL Server 2017 has 140 as compatibility level. SQL Server 2022 will have 160. So, and you might have noticed when you are restoring a database from your lower version to the higher version, the compatibility level does not change by default. You will still see the same compatibility level. So here, for example, if you are upgrading or if you are restoring a database which is backed up in SQL 2019, and if you are restoring it in 2022, then in that case the compatibility level in that particular instance will still show 150, and it will act as 2019 version only until you change the compatibility level. The next one is the containment. So in database, there are many objects that is using the server level features like logins in the master database. So the contained database keeps its own metadata and security information inside its own file, making it a self-contained unit. So why we use the containment? The primary goal is to portability. So here, when you use the containment, we will not have any orphaned users. And when users occurs, when you are restoring a database which has few users, and if you restore that particular database in another instance, and in that instance, if that login which belongs to that user is not present, then those users will be called orphaned users. So when you use this containment options, it does not need any relevant login, and this will definitely prevent any orphan user while you restore your database to another instance. It will also be helpful for easier high availability. If you use always on availability groups, you don't have to manually recreate logins on every single replica server. So in that case also you can use the containment. Here we have two types of containment. Let me show you in the database. You can go to the properties and you can go to the options. Here you will have containment type. One is none and one is partial. So when you keep it as null, it is a standard model. The database depends on the server for logins and certain configuration. When you use the partial one, the database is mostly isolated. You can create contained users with the password that exists only within that database. So this is about the containment in SQL Server. So now let's understand about the database states. In SQL Server, database state tells you whether your database is accessible, and if database is not accessible, so what is the reason the database is not accessible. You can check these states in the SQL Server Management Studio. You can also check this by using the queries sp underscore help db, and once you run this, it will tell you the information or the state of the database. Here you can see status is online, right? So this is about how you can check your database status. Now let's understand what are the different status of the database. One is online. First one is the online, and this is the database when this is a state when the database is fully functional and available for use, so user can connect and the primary file group is available. If a non-primary file group is offline, the database remains online, but those specific pieces of data are not reachable. So in case you have a primary file group and a secondary file group, and if your secondary file group has some issue, you will still see the database as online. So here you will not need any action. This is the most healthy state of the database, and in ideal scenario, the database should be online in any of the system. Second is the offline state. It means the database was explicitly taken down by an administrator, and in this case, the files are still on the disk, but SQL Server Engine has closed them. No one can connect to it. And why we use it? To move the database files to a different drive or to ensure no one is using the database during the maintenance. And to make the database offline, you can simply right click on the database, you can go to the task, and you can make it offline. You will mostly use this feature while you are moving your database files from one disk to another disk. Read-only state. So here, read-only means it will only be used for read-only purposes. User can query the data, but no one or even not SQL administrator or SA can modify it. You will use it only for select statements. There will be no insert, update, or delete options or operations allowed. Often it is used for the archive data that should not change, or many times you will also see this in the secondary server in a read scale availability group. So this will basically use to offload the workload to the or offload the read only workload to the secondary instance. Next is the suspect. So when the database is in suspect mode, it means the database has failed the startup recovery process and is likely damaged. So here in this case, the transaction log is missing or corrupted. Maybe the database file are being held by another process like antivirus or maybe a hardware failure. So to recover this database, you need to check the SQL Server error log and you need to respond accordingly. So next is restoring. When you are restoring your database, this will be in restoring mode. If you are restoring your full backup or the differential backup or the log backup, this state you will see in your database. This will show in the restoring mode. Next one is the recovering. The database in this case is starting up and it is doing roll forward or roll backward all the transactions to ensure the consistency. It is temporary unavailable. It means this you cannot use this database until the database is fully recovered. So there are few databases you will see that those databases are very, very huge in size, or the transaction log is very huge, or maybe you are performing some kind of bulk insert in that database, and if the database got restarted, then it needs to do a lot of roll forward and roll backward. So it may take a lot of time to recover the data. So it is very important to see why the database is in recovery mode for longer time. Other is the emergency mode. So it is a special state set by an admin to allow access to a suspected database for troubleshooting or exploring data. So these are the main database states. And now we'll look into some of the interview questions that is related to the topic. First is, what is the advantage of using file groups? So there are multiple advantages of using file groups. First, it enhances the performance. Consider a database which has some critical data and also non-critical or rarely used data. So you can keep both of the data in different file groups, and the critical data you can keep in a faster SSD drives, and non-critical data you can keep in HDD or slower drives. By this, you can reduce the disk contention because the read-write heads are not fighting over the same physical space in the same drive. So it definitely improves the performance. Second is it helps in the disaster recovery. So if your database is very huge, and if you try to restore it, it may take hours, and it may take days as well if your database is really huge. So in that case, you can keep your critical data in a file group and non-critical data in different file groups. And while restoring, you can restore your primary file group plus critical data file group first. And by doing this, your database will be operational, and later on, you can restore the other file groups. So this is another advantage. Advantage is maintenance. If you have a very short maintenance window, and if you have kept your databases in your data in the different file groups, so you can do the maintenance only for the data files or the file rows which are very critical, and you can avoid the maintenance for the non-critical data. So these are some of the advantages of using the file groups. Second question is, how do you resolve the log file full issue or 9002 error? So first thing, you need to check if the database has the full recovery model, and if it is in the full recovery if it is in the full recovery mode, then you need to check if the log backup is configured for that. If the log backup is configured, check if it is working properly, if it is not getting failed. Second thing, you can check the long running transactions. Sometimes user can run or start a transaction by begin tran, and they forget to end the transaction. So it will keep growing the log, and it will avoid the truncation of the log. So you can check that. Other thing, you can check that if your log file is limited in max size, so you can increase the limit. If the limit is max size already, then you can check if the space is there in the disk or not. And if there is no disk space in that particular disk, and your file is full, temporary, you can add another log file in different drives. And once your transaction is completed, you can again truncate your log, and you can shrink your log file. Then later on, you can empty your secondary log file, and you can remove that secondary log file. So there can be different approaches to resolve this log file whole issue or 9002 error. The next question is, can we have more than one secondary data file in a primary file group? Yes, we can have multiple secondary data files in a primary file groups. But if your database has the different kinds of data, like critical data or non-critical data, it is advisable to keep those in different file groups. But there is no limitation. You can keep multiple secondary data file in a primary file group. Next question is it fine to keep multiple log files in a database? Why or why not? It is not fine to keep multiple log files in a database, but yes, we can have multiple log files. As few seconds back, I have explained the example. In case of log file full and you don't have space in the drive, you can have multiple log files, or you can add more log files in your database. But it is not advisable, because when you recover your database need or your SQL server needs to manage all the files in the server in the database. So it will have extra overhead for the SQL server to manage those files, and it is not giving any advantage of having multiple log files, because your log file is getting filled or getting read sequentially. So even if you have multiple log files, your data will be limited to maybe limited to one log file. So it is not advisable to keep multiple log files in a database. Next question is, what is page split and how does it impact the performance? So in SQL Server, page splits occurs when a data page becomes full, but a new row needs to be inserted into the middle of it to maintain the logical order of an index. In that case, the page does not have any space. SQL Server splits that page and it creates a new page and it moves approximately 50% of the rows into the next page. So this is called the page split. And uh, while page splits happens, there is excessive disk IO. SQL Server has to do a lot of work to move those files or move those rows from one page to another page, and it needs to lock the both pages, and then after that it will move data from first page to the second page, and it will also have the index fragmentation, because when your page splits are happening, it is not mandatory that your next page will be sequential in order. It can be in different place in a same drive. So again, this is the physical fragmentation. So too many page splits is not good for SQL Server performance. What is your approach to resolve the suspected database? So when a database is in the suspect mode, it means that SQL Server engine attempted to open the database, but it has failed because of critical error. And mostly this suspect database error is related to your disk or your missing files or maybe the corruption in the file. So to resolve that, you first need to check the SQL Server error log. What is the main cause of this database suspect mode? Maybe you can try to refresh it. You can try to set the offline and again make it online, or you can if it does not work, you can move the database into emergency mode. You can run the command like alter database name set emergency. Then you can run the dbcc check db, and there are a few options no info message or all error messages. You can check all the errors in the dbcc check db, and if there is nothing working, you need to accept some of the data loss. So you can use dbcc check db with repair allow data loss. So these are the ways to resolve the suspect database error. Next is, what are the recovery models of the system databases, and can you change it? So the default recovery model of master, MSDB, and TempDB will be simple. Model can be full, it can be simple as well. So next, can you change it? So yes, we can change the database recovery model in master, MSDB, and model, but in TempDB you cannot change the recovery model. So this is it for today. I hope you have learned something new today, and I would request you to comment what new learnings you have found in this video, and I'll see you in the next video. Till then, take care. Bye.